Hello, hello. Three angle bisectors, constructing angle bisectors. So here you have an acute triangle. So it does not matter which angle you pick. I'll pick any angle, does not matter which angle you pick. I'll pick this one. So pointing into the compass, right on the vertex. And I'm gonna, now I don't wanna go way out here and interfere with these two angles. So I'm gonna say, divide this into thirds. I'll say, this portion is going to be for that angle, that area is going to be for angle D, and that area is for angle G. So I don't want to go way out here. You can, but now you have arcs all the way over interfering everywhere else. So I'm going to keep my arcs here for this angle in that area. For angle G, keep them close to angle G, and for this area, keep them close to angle D. So make a swinging arc. This arc should intersect these two sides of the triangle. That's it. Now I could do all this. I could, but I don't need to. So that I can't even. Ooh, there, I can't erase it. I only need those two points. So using this point and this point, act like you make a perpendicular bisector. So there's the full distance between the 2 points. That's half the distance. Go more than half the distance. I usually try to use that same compass setting. So it's going to go right through E. Okay. Actually, I'll make that a little smaller. So, semicircle once. Ooh, I'm a little bit off right there. It's not right. Oh, that one counts for an error. Yeah. All right. There's one. So this has to be right there. There we go. Swing another arc. So these two arcs meet there and there. It's the inside one and the inside one. And it should go right through angle E. That point right there and there. Okay. Come on. Boom, boom. There's one angle bisector. Do it again for this one, angle D. Swing an arc, goes through both sides. Using these 2 points of intersection, act like you make a perpendicular bisector between those 2 points. So, swing a half circle. Do not change the setting of the compass. Go right there. Another half circle. So now, see how these arcs start interfering with each other? These two arcs meet right there. That's the point I want right there and right there. So using these points, zoom, boom, 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 boom. This is an angle bisector for D. Do the same thing for G. So I could be over here, but now I'm interfering. So just visually, I'm going to make this. There we go. Now this arc, I'm going to use this point and this point, using these 2 points of intersection. Using those 2 points, act like you make a perpendicular bisector. That's the full distance, that's half distance. Make sure it's more than half, so that goes right. So I'll use that distance. So, do not change the setting in the compass. That one, go right there. That one, and now that one. Right there. And there we go. So they intersect here and right there. Should go right through angle G. All right. Now, I don't know if you can see that, but for me, there is a tiny gap right in there. And I'm not happy with myself right there. But if you have a tiny, if you have a tiny gap, that means this is a little bigger gap. Hopefully you can see that gap right there. You see some white space. You don't want that white space in there. But that means if you see a little gap, a little hole, that means you made a little boo-boo. It's not quite right. If you see a bigger hole right there, a bigger gap, that means you made a bigger boo-boo. There's at least one mistake there. Okay. So That is going to be called the in-center. How do you know if that's going to be done correctly? Okay, they all should meet at a point, so I'm just a hair bit off, but that's the in-center. This should be equidistant to the three sides. I'm not going to go to that point. I'm going to go to the shortest distance. So I'm not going from here to there. Do not go to there. I want to go to the shortest distance. So there, right there, that's the shortest distance to a side there. So I'm just touching that side. If the thing would, right? Try it again. There we go, now it's working. All right, let's try it now. So boink. Okay, when I make this circle, oh, come on. When I make this, it should touch all three sides. So, this, make a circle, 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 circle. Their circle is equidistant to the three sides. So this circle should just touch, and just touch all three sides. Just touches, just touches, just touches. Now for me, that is a little bit off, but hey, students, that's good right there. That point is called the in-center, and that circle is called the inscribed circle. Okay? So we're in an acute triangle. Now if it touches all three sides, perfect. If you do this, and let's say you get a triangle that does, I'm going to show you how to make a boo-boo. This one's going to do, this is going to be a mistake. It's going to be, come on, there we go. I hope you can see the difference in these colors. It touches right there. That one's a little bit, does not go, it goes, touches twice. It's outside, and this is outside. So it touches once. That's, no, that was off. The red one, I don't know if you can see that color, but that right there is much better. This one right here is off. It's off. Okay. Do it again for obtuse triangle. Obtuse triangle, same thing. We're going to start with any angle. I'll start with the obtuse angle. Going to do an angle bisector. Make sure that's right on the vertex, right there. Construct an arc. Okay, using that point and that point, we're going to construct a perpendicular bisector between those 2 points. Dun, dun. So swing a piece of paper. Whoop. Do not change the setting of the compass. Now I'm going to put it right there. Whoop. There and right there. Okay, bonk, 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 bonk. Okay, that's angle A. Now let's do angle S. Swing an arc. Intersects in 2 spots. Right there and there. Using these 2 points of intersection, we're going to act like I make a perpendicular bisector between those 2 points. So, do not change the setting of the compass. And it's right there. Not there, but right there. And starting to get a whole bunch of arcs going on here. So that one and that point right there. Boom, 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 boom. That's an angle bisector for angle S. Do the same thing for angle T. I could go way out here, but it's in all that mess. There's a nice clean area right there, so let's go over here. Swing an arc. This arc intersects twice, there and there. Using those 2 points of intersection, doink a doink. Make a perpendicular bisector between those 2 points of intersections. And that point right there. Not that one, but that one. Swing the paper, not the wrist. There we go. And look. We have down here, right down here. T, right there and right there, that point. That's a dunk. Boink. And it's okay. Okay. Now I'm going to, that point right there, the three angle bisectors should meet at one point of concurrency, and that point's called the what? The in-center. This circle, that point, sorry, the in-center is equidistant to the three sides. So we should be able to make a circle that touches just the three sides. So do that again. Oops. Pointing of the compass right in the in-center. I'm just gonna go the shortest distance to that side, to right there. Move that stuff. And this should, oops, move that stuff off to there. Ouch. Move that. So, okay. Come on, there we go. Oh. Okay. So, see how this a little too far, that one's okay. It's a little off, but that one's definitely off right there. So I'm a little off here in my in-center. Okay. So it looks good from here, but when you make your circle, not as good as this one right here. So it's a little bit off. Okay, that circle is called the inscribed circle. Okay, three angle bisectors meet at a point of concurrency called the in-center, and the in-center is used to find a point that is equidistant to the three sides of the triangle. If you make a circle, that circle is the inscribed circle. Okay, boom. Good luck, guys. Bye-bye.